Okay guys, so today we're going to look at some of the problems that we've been having in the lab dealing with microscopes. I know we've been getting confused on these two. Been dealing with magnification and the field of view, and been getting those two mixed up and not really quite grasping the concepts of how they're related. We're going to address those today. So we'll start off with magnification. We all know that we have our ocular lens, which is 10 times, but then we have our objective lenses, the ones that you can change, and those are our low, medium, and high, which are 4 for low, 10 for medium, and 40 for high. So that comes out as a total magnification of 40 times magnification, 100 times, and 400 times magnification. We also have the field of view. That is what you see when you look through the eyepiece at the specimen that you are observing. So what scientists use are called microns. We've been measuring the objects that we've been looking at, and typically that's what everything gets measured in, and it takes 1,000 microns to make up 1 millimeter. So when you're actually observing something, you're going to see it, say you're looking at a cell, and you determine that it comes out to be 500 microns, then you can easily convert that into millimeters. So now let's talk about how these two are related, magnification and field of view are related, and why we might mix some of these up. As we zoom in on a specimen, we are increasing the magnification from, let's say we go from 40 times to 400 times. What did that increase by? 10 times. So what we did was go from the low powered, and we looked through this, and what we saw was cells that looked like this. And when we moved up to the high powered objective lens, maybe we saw something like this. Now my question is, did the cells actually get bigger? Well, no, we just got closer. So if we think about it in terms of real life, we can say you're standing 2 miles away from a water tower. That's my poorly drawn water tower, and there's you looking at it. It looks pretty small at that distance, right? Let's say you walk up next to it. Did the size of it actually change? Or did the perspective we had, the distance between us, change? Just the distance. Just the way we are looking at it. Now, field of view is the opposite. As we get closer, the object still doesn't change size, but what we see gets smaller and smaller. Do this. Think about your vision. What you are looking at to watch this right now, the YouTube video, that's your full field of view. Your computer or phone or iPad, that is in your field of view. Now, take your left hand, put it over your left eye. Your field of view just decreased by roughly half, but the size of what you were looking at did not change. Now that may not be the best example, but I'll explain it more clearly shortly. Let's actually pick a reference you can relate to and use. Pretend we're looking through the eyepiece right now, and we're on the lowest power. So 4x, but we have the ocular piece at 10x, so it's actually 40 times magnification right now. And we put a slide in there, and we're looking at cells. If we go to bump this up to get a closer look and see what's going on inside the cell, let's say we're going to 400 times, which is the high power multiplied by the ocular lens, what we would see is maybe something like this. Zoomed way in. And if we go back, think about what we just did, went from these smaller cells having a known field of view, which we've determined, talked about it in class, from here to here, what we can actually see 5,000 microns. So this whole spectrum that we see, our field of view, the 5,000 microns, is on the low magnification. When we jumped it up to high magnification, the size of the cell didn't actually change, just what we saw. And because we went up from 40 to 400, it's a power of what? 10 times? And we know that we saw originally 5,000 microns was our field of view, but because we went up in magnification, we got closer, so our field of view was cut down by the same rate, 10 times. So the field of view went down by that same factor. So now from here to here, change that color so you can see a little bit better. From one side to the next, went down by a factor of 10, making the whole field of view 500 microns. So if we do some examples here, we take what we're looking at under low power, and let's just say that we're looking at a microscope with 10 times ocular, and it has a 5 times objective lens, which comes out to a total of 50 times magnification on low. And we know that on low power, the field of view that we have right here is 3,500 microns. What we want to know is if we take that and switch it to the high-powered objective lens, which still has the 10 times ocular lens, but we go to 50 times objective for a total 500. What is our new field of view? So the way we do this is pretty simple. We know that the original field of view is 3,500 microns, and we know we went from an original 50 times to 500 times by a factor of 10 times. So you know that the magnification is increasing, so that means the field of view must be getting smaller. When magnification goes up, our field of view decreases. So what we do then is simply divide by that amount of magnification. Since we went 50 to 500, a factor of 10, we just divide by that factor of 10, and it comes out to 350 microns is our new field of view. So this one I'm going to leave up to you guys. I'm going to give you another example, and I guess you can leave a comment down below or come up on Monday and ask me. But let's start off with, we're looking through a microscope and our total magnification is 60 times, and we know that the field of view is 362 microns. We are going to go down, zoomed in too far, so we're going to go down to 30 times magnification. What is the new field of view after we go from 60 to 30 times? Now another quick thing I'll review is some people were having trouble with was determining the size of what you are observing. So let's say we are looking at, this is two different examples here. We'll start out with this one, that we're looking at two cells on high power at, let's just say we know the field of view is 400 microns. Well, to determine the size of these cells, we just look at the whole field of view. From here to here, we know it's 400 microns. And this cell right here takes up pretty much half of the field of view. So we know that with this half and this half, divide this number by 2, and what do we get? 200 microns. Now, it's not always this simple. Sometimes we're looking at cells and they look like this, spread out and small, or we could have it where they're a little bit larger and still scattered out, but you can roughly estimate the size. Let's say we are looking at a slightly lower power here, and we know the field of view to be 2,000 microns. Well, if we look at each one of these, we could say that pretty much if we took this one here, put this one in the middle, and put this one over there, it would stretch the entire span of the field of view, which would mean that we'd cut it into thirds. So having 3 equal parts means we would divide the 2,000, the whole field of view, by 3, which would end up coming roughly to 660, call it 667 microns. Now let's just do one more example that I'm going to leave it up to you guys again. Like I said, you can either write below and ask for help, and I'll try to get back on and help you guys out, or talk to me on Monday, or help your classmates out, talk to them on the phone or whatever it is. But what we'll do is, let's say we know the field of view of a specimen we're looking at. We know the field of view is 2,500 microns, and it's a very small cell, and it would take 123 to span all the way across from one side to the next. It would take 123 to get all the way from one side to the next. How big is each individual cell? Well, I hope this helped out a little bit, guys, and if you guys have any questions, we'll be in at 7 o'clock on Monday morning, so if you have anything, stop on by or leave a comment, and I'll try to get back to you guys, but I can't promise that I'll get up to it this weekend. But good luck on Monday, guys. See you then.
Made with Doodlecast Pro.